Hey, Trans Math class, we are going to do the notes for section 3.5. And that's going to start with just a review of multiplying fractions by, it says by multiplying across. So again, if you have a whole number, you always can put a 1 underneath that, and then we just go across the 2 times 1 and then 1 times 3. So that would be 2/3. This already has numerator, denominator, so we just go straight across 2 times 5 and 5 times 8. So that's going to be 10 over 40. And again, we have a whole number here, so let's think of a 1 as the denominator. So we can go 4 times 3 and 1 times 4. So that's going to be 12/4. Straight across here, 1 times 10 and 2 times 12. So that's going to be 10 over 24. Number 5, 3 times 4 and 4 times 5. So that's going to be 12 over 20. And here, 7 times 10, 9 times 20. So that's 70 over 180. And here again we have a whole number, so let's just think of a 1 on the bottom. 6 times 7 and then 1 times 8. So 6 times 7 is 42. 1 times 8 is 8. And last one, 8 times 9, 9 times 11. So we're going to have 72 over 99. Now in each of these problems, we end up with some fairly large numbers in the numerator and denominator. And what we're going to see now in this section is that we could do some simplifying, and that's what they're going to have us do. And I'm going to show you some shortcuts to simplifying and then just the basic technique of how you put a fraction into its simplest form. Okay, but before that, it looks like in the skills review, we're going to review how to write down an angle and how to name them. There's some different ways that we can do it. And if you remember from previous video, it's called the vertex. That's where the corner of the angle is. That's the important letter. So we can just name an angle with just the vertex, angle B. Also, we could name it with 3 letters. As long as we put the vertex letter in the middle. So I could say it's angle ABC. Now you don't have to do all of these, but I'm going to show you all the ways that they could be named. So you could say angle ABC, or we could go the opposite direction, angle CBA, as long as that B is in the middle. Angle CBA. So again, you don't have to list all 3 of these. Probably the easiest is just to use the 1 letter. Okay, but I'm going to show you all the different ways you might see an angle named. Okay, so similarly, we could go angle E for number 2. We could go angle DEF, or the other direction, angle FED. Okay, for number 3, we can say angle W. We could say angle XWY. We could do angle YWX. Number 4, we could say angle M. We can say angle LMN, or finally angle NML. Again, just notice that that vertex letter always has to be the middle letter when you use the 3-letter technique for naming angles. Number 5, we could do angle T. We could do angle STU, or we could do angle UTS. And number 6, we could do angle Y. We could do angle XYZ, or we could do angle ZYX. Okay, so those are the ways that we can name our angles. Okay, so going back to the main idea of this lesson, which is going to be simplifying fractions, okay? And then, so what we're going to do with simplifying fractions is we're going to talk about factors, okay? So factors of numbers are numbers that are smaller than that number, but would divide evenly into that number, or that we could multiply those small numbers to make that bigger number. So for example, the number 12, any factor of a factor of any number, I should say, is always 1. So you can always take 1 times that number to get it, right? Another, if it's an even number, 2 is always a factor of that number, right? Any even number is divisible by 2, so like 2 times 6 would give us 12. So there's kind of giving us a visual here. And then finally, we could do with 12, 3 times 4 is also, okay? So we'd have all the factors of 12 would be 1 and 12, 2 and 6, 3 and 4. Those are all of the factors of 12. So when we're simplifying fractions, what we're going to look for are the common factors. So for example, if I had I'll just show you what they're getting at here. If I had 12 over 16, and that was my fraction, and they said, hey, put this in simplest form, simplify it, then what we'd want to think about are, well, what are all the factors of 12? We just listed those, 1, 2, 3, 4, 6, and 12. And then what are all the factors of 16? Now we could go through that in a similar process. 1 times 16 is 16, 2 times 8, and then 4 times 4. And so all of the factors of 16 are 1, 2, 4, 8, and 16. Okay? So what we're looking for then is the greatest common factor. And if we look at those numbers, 4 is the greatest common factor. So what that means is that we could divide both the numerator and denominator, just like when we multiplied sometimes to make when we were trying to find common denominators for adding and subtracting, we can also divide the numerator and denominator by a common number. Okay, and if we do it to the same thing to the numerator and to the denominator by dividing, then it's still an equivalent fraction. We're just going to put it down into its simplest form. So we see that 4 was the greatest common factor. So if I divide 12 by 4 and 16 by 4, that's going to make it a simpler fraction that's equivalent. So 12 divided by 4 is 3, and 16 divided by 4 is 4. So 3/4 would be the simplified version of 12/16. Okay. And so they're going to talk about we can easily find or pull out factors. When they say pull out factors, that really just means like divide it, like what I showed on the other example. Okay, and so they're going to talk about pulling out factors here. Let's jump into some examples. Okay. All right, so if we have 8/12, right? So it says find the greatest common factors of 8 and 12. So let's start by just seeing if we can figure out, some of the factors of 8 and some of the factors of 12, right? So with the number 8, right, if we have 8, and maybe you did this before, you did like a factor tree, we could do 1 times 8, we could take 8 and we could break that down into 2 times 4, we could break the 4 down into 2 times 2. So that's a way that we find some of the prime factors, but let's do this maybe in the way that we showed it before. So for the number 8, we could have 1 times 8. So I'm just going to list 1 and 8 as factors. We could have 2 times 4, and I think that's all that we have. We have 1, 8, 2, and 4. Those are all the factors of 8. Now with the number 12, what we did before, we could take 1 times 12, so those are factors, and we could do 2 times 6, and we could do 3 times 4. Now when I look at all of these numbers, what's in common here? What I see in common is 4. I also see a 2 in common, but 4 is the largest of those factors, right? And so when I think about this, so since 4 is the largest, I could come over here and I can divide both 8 and 12 by 4 and get my simplest version, which would be 2/3. Okay, so 2/3 would be using the greatest, when they say GCF, that means greatest common factor. Okay, and what we did was we found that by just kind of listing out the factors here. Okay, just think of the numbers that can multiply to equal that number. Okay, so for find the GCF of 6 and 12. So if I'm thinking of 6 and 12, the numbers that multiply to give me 6 would be 1 times 6, and so these won't really be, this is the way I did it before, just because I'm thinking of, okay, if I multiply those, that gives me 6. I could do 2 times 3, and I think that's all the factors of 6, right? 1 times 6 or 2 times 3. Now with 12, I could do 1 times 12, or I could do, and I've done this before, 2 times 6, or I could do 3 times 4, right? So those are all of my factors of 12. Now when I look at these lists, I've got a 6 here. I've also got a 6 here. That's my greatest common factor, my GCF, okay? So that means in this I can divide by 6, okay, and I can reduce each of those by 6. So when I take 6 divided by 6, that's just 1. 12 divided by 6 is 2, so that can simplify down to 1/2. Okay, so as we do these problems, I'm not going to write out all the factors of each of these numbers, but you may have to look at your multiplication chart and see if you can find the common factors of 3 and 9. Okay, so you might want to go down the 3s and the 9s and just see where where do those numbers appear. Okay, so with 3 and 9, hopefully you know that, well, many times the top number of your fraction is a factor of that bottom number, and then we can just divide by that, which is the case here. We can divide by 3. So 3 divided by 3 is 1, 9 divided by 3 is 3, so 1/3 is the common factor. Okay, so I would start by asking yourself that question. Can I divide by whatever that numerator is? So here, 4 and 12, can I divide 12 by 4? Yep, and I can certainly divide 4 by 4. So that's my greatest common factor, so I get 1/3 for that one as well. Okay, in number 3, I've got 2 and 6. Well, can I divide by 2 with the 6? Yes, I can. So I can divide by 2 in both the numerator and the denominator. It's going to give me 1/3 again. These all happen to be 1/3 so far. Okay, now in this one, I have an 8 and a 12. Can I take the 12 and divide that by 8? I don't think so, because that's not going to work. You can't take 12 divided by 8 and get a nice, even whole number, so you can't really do that. So let's think of some of the other factors of 8. How about 4, right? Because that would be the next factor that we could divide 8 by. And does 4 go into 12? Yep, it does. So, we can just divide by 4 on the top and on the bottom. So 8 divided by 4 is 2, and 12 divided by 4 is 3. So we'd get 2/3. And in number 5, so if our top number is 4, does 4 go into 8? Yes, it does. So there's our answer right away. So probably your best bet is to start by looking at that numerator and say, well, can I take the denominator divided by that? Does that work out? And it does. So this would just give us 1/2, or 1/2. Okay? And that's it. That's what we're going to kind of start working on, is simplifying fractions in this section.